Hello, my name is Juan Alberto Velasco.
My name is Manuel Ortiz.
My name is Jorge Alvarez and we are here to present the automatic window blind system. Managing natural light is often inconvenient. Bright sunlight can overheat rooms while dim light forces us to use artificial lighting. Studies show that energy consumption for lighting and cooling accounts for over 20% of household energy used globally. This highlights the importance of efficient solutions like ours. Our system is designed to solve this by automatically adjusting blinds based on sunlight. This improves comfort, reduces the use of artificial light, and helps to save energy. Additionally, motion detection ensures the room is well lit when occupied. Our main objectives are to develop an automated system that adjusts blinds using sunlight intensity, to reduce energy consumption by optimizing natural light usage, and to provide user-friendly features like manual controls and status indicators. That's why we created the automatic window blinds system.
The construction process and the components. This is our project. Here we used like a lot of we used 3 sensors, well 4 because we add another button, and we use a servo motor and the functions of infrared sensor, and 3 LEDs, 1 blue, 1 red, and 1 green, and the resistors, 3 resistors, 1 for the LDR that is a resistance of 330, and 2 resistance of the buttons that they are of the SK. And okay, the functionality of this, the infrared sensor, is like when I pass walking, boom, the sensor detects me and opens, and if detects me, it's going to open, and the LED is going to be green because it's open. So the window is up and the LED the window is open, and we can do this. It's a delay of 3 seconds, so boom and boom, and then this is the button 1 here, text me, but button 1, when I click it, it's going to up, and it's green, so when I another, it's red. So it's click on it on the button, and it's going to be high and in 0 grades or 100. And the next is the LDR, that is the light dependent resistor, and is detects sunlight intensity. So we put a new button because the button is going to if I click on it, it's blue, and it's going to, the LDR is going to be like on. So now, right now, there is a lot of light, so it's going to be high. So we put like this, and another time because it's a lot of. But now it's because there is like in the night, so there is no light. And this is the functionality of these 2 because they are connected. The button is connected to LDR to open, so it's blue. So I click it, there is not going to function the LDR. It's disconnected. So this is. And the process included on this project is assembling the components on the breadboard and ensuring the proper the connections, then testing each component individually before integrating them, and working closely with the code and to match the circuit functionality with the code logic.
Hello, Nestor. This is the code of the the electric window. First, I include the servo. Then I put the servo with number one and the three variables: persiana, detecta, y el LDR active. In the voice setup, I put the servo attached in the number 8, the pin mode of the sensor infrarrojo, the 3-bit mode of the LEDs, 2 of button, and 1 of the LED rep. Then I put the serial begin for show the light, and 1 delay. And first the servo write in 5, digital write LED red is in high because the window is closed, and delayed 2000. In the boil up, I put first the sensor infrarrojo, and I put if the sensor infrarrojo detect a hand or everything, the electric window open and the LED green is high. And in the else, I put the if the if the sensor infrarrojo detect a hand, the window closed, and the LED red is high. And then I put a button of automatic use, and if you put the button, the window was open, and the LED green is high, and 1 delay of 1000. And if you put the button in another time, the window was closed and the LED red is high. And then I put the other button of use the LDR. This button active one LED is blue, and when you put the button, the LED blue was high, and LDR is in functionality. If the LDR detect a light more 250, the electric window was open, and LED green was high, and the LDR detect light less 250. The electric window was closed, and the LED red was in high. And this is nuestro code of the final project, and thank you very much.
In conclusion, our automatic window blind system addresses the problem of inefficient natural light management by automating blind adjustments. The process involves designing, building, and coding, which taught us the importance of teamwork and integration. Our system is not only energy efficient, but also improves comfort and convenience. The project highlights how simple yet innovative solutions can make a significant impact on everyday life.
In this project, I assemble the circuit and ensure all the connections like that they work correctly in the protoboard and Arduino, and also I work with all my partners doing this or doing the code that was a little difficult. So I work with my partners, and then I learned about integrating different sensors and servos effectively, and like doing these connections, like doing a good project that can be in the real life because it has a lot of sense in real life, and I like it a lot. I like it a lot in all the semester because I learned about these servos, functionality, LEDs, sensors, all that. And I like the testing phases, like where we saw the system functionality, like today in with the teacher, Nestor, in the classroom when this project worked. So it was good. And finally, the biggest challenge was the code, was the part of the code with this button because we learn how to put a button with LDR and how to put the LDR with the button that can be on and off. So it was a challenge, but with my team, it was good.
And my personal conclusion will be that I learned to design the physical model and KID system. I learned about the KID modeling and 3D printing. I enjoyed seeing the design to come to life, and the most challenging part was aligning the motor with the blinds accurately.
Hi Nestor, that's my conclusion of the final project. First, I wrote and tested the code for the system. I learned to use Arduino functions like switch case and sensor inputs. I enjoyed debug and optimizing the code. The most challenging part was synchronizing the code with hardware responses. That's my conclusion, Nestor. Thank you. I love it.